Welcome to our presentation on the value of data observability and discoverability. Now, I'd like to begin this talk by acknowledging traditional custodians on the land which we gather today, to pay respects to their elders past and present. And I extend this respect to all Aboriginal and Torres Strait Islanders people present with us today. Cool, so for today's short journey, myself and Abdi, we're going to be your tour guides, and we're both data engineers, or should I say metadata engineers at Block. And we're here to show you the continuation of the transformations our business has gone through in the past year. So we presented last year, presenting this year, so the transformation, continuation. So let's just talk about the beauty of decentralization, right? Multiple data teams, we operate in a distributed manner. So that is, if you think about it, a core data engineering team, most of us here are data engineers, we unfortunately have to take care of all the foundational tools and frameworks. So shout out to all of you guys out there. And the curation, the consumption of the data, it is managed independently and used in a self-serve manner. And yes, as Joe said, some of you may reinvent the wheel in your own creative ways because you don't know what's been built or what exists. And so you start to see the challenges of data observability and discoverability. And these issues, they definitely become much more amplified when it comes to larger decentralized data environments. And Block, we are a large organization. And we are big fans of objectives and key results, OKRs for short. Please pay attention, right? Objective and key results, OKRs, they're important. And why is it important? Well, we need to measure what matters. And for you, most of you guys here, that's success, right? Success in a business. So I'm just gonna dive into our objective and key results. The purpose, the why. Well, we are here to empower our users to solve business problems that depend on data. And not just solve them, right? But to do it efficiently. And the objective, the what. We are here to make life easier for our users to find, to understand, and to trust the data. Now, for example, how can I easily observe and discover our data? I'm sure all of us here, we have come across failed pipelines or a stray table that is critical in production, but the person who built it left years ago, took all the logic with them, and now no one wants to touch it because it's just sitting there. Or if you remember from Joe's amazing talk, right? Finding out that you spent a whole sprint reinventing the wheel. So how can we tell that this whole metadata initiative is going well? Well, for us, we hold ourselves accountable with key metrics, right? How many users are using your solution? Why does it matter? Well, we are not here to build a solution that no one uses, right? We're actually here to solve pain points and add value. So it's fair to say that if users are adopting it, then they are getting value from it. So let's take a look at 22 versus 23. Right, we started off with about 100 users over a 6-month period, and about 30% of our data users. And this year, we have over 240 users. And if you think about it, right, that's 2 times the number of people here plus more using our solution right now. And that's just at a company, right? It's not open source or anything. So there you go. Looks good on paper, but eventually, right, budget person always comes knocking on the door asking about funding. Let's be realistic, right? So let's talk numbers to get you interested. This is for your managers, your executives, high-level people, right? Benefit across a whole data team, estimated savings, 30,000 hours. Simple. The cost, it's a bargain. It's $600 per month, not including our salary costs, of course, but the solution itself, cheap, and it's effective. So now you can literally see the value of data, observability, and discoverability as a metadata initiative. So I'm gonna go through the high-level technical overview on how we made it possible. Cool. Oh, forgot the slide. I'll just put the numbers up there so you can see it. Cool. 30,000 hours, US 600. Pretty good numbers. All right, so I'm just gonna go through the high-level overview. We'll start off with a very standard setup where jobs pull data from a source like a connector or an API. You dump it into data warehouses. And for us, we don't have just one, we actually have a few. So we have Redshift, we have Snowflake, we have S3. Now, we also don't quite follow the traditional data lake environment. We actually operate in more of a data hub. And if you don't know what a data hub is, essentially on top of the usual BAU processes and reporting, we also work on critical business cases and also decision support processes. And now when consumers have questions, And they always do have questions, right? They come to our data support channel on Slack. Now, we do have source subject matter experts that help answer these questions, but it's on a best effort basis. So actually, it's us poor data engineers to answer these questions, right? And so if you think about it, we're only human. We do get tired of answering questions. So we decided, okay, why don't we automate the answering of these questions where possible? And at the core of this is our metadata refresh workflow. At the highest level in terms of technology, it's just Python and SQL. My good mate Abdi is going to talk about it in more detail, so just hold on to your papers for now, take my word for it. Cool. Now to kickstart this refresh workflow, we ingest all the metadata from our metadata warehouses. So Redshift, we hit the system views, Snowflake, we hit them, S3, whatever we use, it doesn't matter, it's agnostic. We just grab all the metadata that we can. Now we've got the data in there, got to go, okay, how did the data get in there? So we start thinking about the ETL jobs that populate them, right? We want to know if the pipeline failed, what time does it run, how often does it refresh, right? Job statistics. So for us at Afterpay, that's Airflow and Databricks, okay? Now that we know how things are populated, we got to go, okay, what are the questions being asked? Because they're the most time consuming. So we went to Slack to get the context of these questions, How does the data get in there? Who owns it? Where is even the data? I don't know any of these questions, right? And as Joe said, WTF does this data even mean? So we actually have a process as well that analyzes the Slack data support questions that we have. It hits the Slack API, runs very simple natural language processing and regex, categorizes the question, dumps it in. So cool. That's a high-level overview of our refresh workflow. Where do we dump it in? A central metadata database using Postgres. And it's in third normal form. Data modeling is important. And I know some of you might be like, okay, why do we have this central database? Well, the idea is that if we store our, let's say, data with a single vendor or a third-party tool, our metadata is with them. It is not with us. And so we realized that owning a centralized location within our company, we never lose the data and we have full control over it. Okay? Cool. So we've got our metadata. It's stored in a central location. And we need to end this journey by having a really nice place to show it off, right? Because the table's a bit too technical for most of us. So for us, we have Amundsen, an open source data discovery platform, and an Epic Explorer, if you know who Amundsen the Explorer is, right? Why Amundsen? Well, we have the philosophy of building what we don't have and reusing what we do have. And we had it as an existing tool. To be honest, it was very bare bones, very buggy, as most open source tools are. But we have now fully customized it to suit our specific needs. And the cool part about Amundsen is that it gives us the opportunity to crowdsource metadata using, let's say, a favorite method of ClickOps, because we all love ClickOps, don't we? You can search for metadata via Elasticsearch, and Abdi will talk about it in more detail. And even better, we can display lineage end-to-end, right? Think about an API, all the lineage downstream, all the tables, all the views, everything, even the use cases. We show that on Amundsen, and that's just few of the features that I have time to talk about today or tease it, right? There's plenty more. But at the end of the day, this is for your analysts, your engineers, your managers, not enough time. You want something easier. So we decided, okay, to top it off, we can create dashboards. We can open up the APIs for usage by any other tool, plug and play, right? Think about data quality as a plug and play solution. Or even if you think about your fellow engineers, right? We can help drive a metadata-driven framework. So many use cases. So awesome. Our users are empowered. They're very happy because they can now find answers. And so why don't we talk about the users using the solution, right? We're all in the data space. We're all in it together, right? So let's talk about the heroes that keep us employed. Cool. Data engineers, most of us in the audience, we're data engineers. Common pain point, yep, my pipeline broke. I need to observe my failures. I need to be able to discover what breaks downstream, right? Data observability and discoverability. Analysts, maybe some of you in the audience or a fellow data analyst, I hope. You need to discover what you have and what they mean, right? What is the, let's say, data type of this column? I don't even know where to get started. Who owns it? I need to talk to them. Or in Joe's wise words again, what does this data mean? Data discoverability. Managers, you're all interested in the platform health. You've got so many meetings, not enough time. Just need a single place to look at and go, yep, that's a number that I can go, my data platform is doing pretty well. Data observability. And let's not forget about our favorite, scary auditors and security analysts, they need to make sure that regulation is happy with us so we don't get fined, right? That means I need to be able to observe, discover everything, and also annoy the heck out of everyone. No, I'm joking. I like you guys. But they care about data discovery and data observability. So you get the big picture, right? The same metadata that we ingest can solve different problems for different users. And now that we have our user requirements and all their pain points, we need to model it in order to fill them, right? So I'm gonna pass it off to my mate Abdi to talk about the what and the hows, mate.
Hi everyone, I'm Abdi. I'm a data engineer at Block. I've been here for about a year. I've been a data engineer for 3 years. And today I'll be talking to you how we use metadata to give context to our precious data, right? Given Joe's awesome keynote speech on data modeling, we all know how easy it is to do data modeling as a practice. So I put this awesome meme for you. You just easily create a new data model and bang, it's done, right? Having said that, Akira in the last slide talked about our different user personas that we have. Data engineers, analysts, managers, and they all had one thing in common. They all wanted more context around the data, right? They wanted the answers to where did this data come from? Who uses it? Who produced it? For what reason? So at the middle, we have our data set. And data is to the data team what cash is to the finance team, right? It's at the core, it's important, we want to know more about it. All right, so how did we add more context? I'm going to demo a contextual metadata data model. Yeah, we didn't skip to the physical model. We actually did the conceptual modeling. Shout out to the team. Awesome. So we wanted the question, for example, where did we source this data? So we simply add a new entity, source. We want to know who consumes it. Easily, just add another entity and make a relationship. Next, we want to know how frequently this data is refreshed or what DAG details. We used Apache Airflow. So for example, we have DAGs that refresh our data. We want to know how frequently it was refreshed, right? And finally, where's this data platform hosted? We use Redshift, Snowflake, Databricks. So for example, yeah, we want to know where it is. So the key point here I'm making is data is at the center of everything that we have, and we wanted to more context. So how do we do that? So at a high level, it looks, hey, you've got a bunch of squares and things. How did this really compose of a metadata model? What did we really do? So we didn't leave it there. We broke down these objects into more granular objects. For example, if you look at dataset, it ended up turning into database, schema, table, columns, descriptions, etc. We then repeated this exercise for the different entities, and yeah. And so the goal again was to give more context to our data. So now we know what metadata we need to collect. I'm going to go over our metadata refresh workflow or ingestion framework, and I'll dive into how we ingest this metadata. So we use AWS Glue, a Glue job, composing of smaller tasks that each hit the source systems independently, then run a bunch of transformations, extract the metadata we need, and then dump it into our metadata database. We also have a two-way sync between Amundsen and our metadata database. I'll go into Amundsen in the next slide. And so whenever a user adds some metadata to them via the Amundsen data catalog, it'll add it back it'll persist in our database. Why is that important? We want our data persisted. We don't want to keep it in a third-party tool. So in the event that we change it from, for example, Amundsen to Data Hub, it stays there, it's persistent, and we can just plug out to a different tool, right? So now that we know what metadata we collected, how we collected it at a high level, let's go into see what our users actually see at the Amundsen landing page, right? So this is where the users will first arrive. This is the landing page. They can see simple questions like where they can contact our team that manages it, some BI dashboards for the managers, from operational reports, and etc. So naturally, next, whenever a user comes and say, hey, I want to discover the data, whatever that's supposed to mean, they enter it, find the dataset object, and they end up at the actual page. So over here, they have all the information about the tables, whether there's column descriptions, and as you can see, a bunch of these messages are blurred out at the moment because these are live in production and we couldn't share them. Sorry about that, guys. But yeah. Thanks to Elasticsearch, we can index all the dataset objects are ranked. So the most popular objects appear up straight away at the top. The first, we can add some regular expressions if you don't know the exact table name, as you can see on the left-hand side. And yeah, hopefully, yeah. And so now a user's got their data set and they said, okay, now what? The next natural question a lot of the time is, where did this data come from? That's where our lineage solution comes into picture. So now the users can see both upstream objects, downstream objects, and what they mean. So if you look at the bottom right, when a user clicks on an edge, they could also see the exact transformation applied to the table. It's only table level lineage at the moment, no column level, so whatever the entire table object is created, it's demonstrated and it's shown there. Having said that, on our journey, there's lots of learnings that we had to undertake, and I'm going to share a couple of them with you now. Engage regularly with your users. I'm not going to kind of tell you guys the importance of how important it is to engage with your users, but for us to solve any problem, we needed to understand our users first. So that's why we kept open dialogue with our users frequently, talk with them, kind of understand them, feel them, and then only then we could kind of work towards a solution to their problems. So these are examples of common messages we'd have with our users. And no matter how much we engage with our users, it doesn't matter if your solution is not good and intuitive to use. That's why we made it important for us to make our solution very user-oriented and the user experience really easy. So over here, we have a real example of a user asking a question. The question over here being, what time zone is this date associated with? A simple column like this can deviate us a couple hours from our workflows. So a subject matter expert or data owner replied with the answer. Now it's finally added back to Amundsen. And at most in a couple clicks. It's really intuitive to use, we believe so at least, and that's why it allowed for almost 5,000 crowdsourced contributions over time. And if you think about it, they're all volunteering to enter this metadata. It's not part of their job description. Just the fact that we get any crowdsourced contributions, we think is awesome. So shout out to the team. A lot of them are here today. And again, no matter how easy it is to do the right things, we need to demonstrate value, like Akira mentioned. So how did we measure the impact that we're making? And it is into our user metrics. How many users we had, how many contributions did they make? So on the top left, we have our power users on the top left, and they're classified as users who use Amundsen at least once a day. And if you look at the top right, active users, they're users who use Amundsen at least once a week. And the bottom, we have our contributors, which is, how many distinct contributors we have. So as you can see, in May, we only started collecting our contributors' data in May. Huge spike up. That was the result of an in-house metadata hackathon that we had. Huge success. And someone awesome, Jared, automated the solution. Thank you. We also decided to gamify it a little, introduce a bit of healthy competition for everyone. So now people can see how many contributions they've made, and don't let anyone beat me. So I was first. I'm joking. I'm probably last. So again, on this point, we need to demonstrate value. Again, there's no point in any of these fancy tool techs if we don't demonstrate any value, and that's what's important to track your metrics, track your user metrics. So as of today, we have about 250 users. I know, Akira, you said 240, but it's actually 250 something. I'm sorry. So we need to automate it to facilitate scale, right? As your users start increasing, you need to automate things. And that's why we decided to automate as much as we could to relieve the burden from our users so they don't have to enter this data manually. And we don't need another hackathon, right? So if you look at this screen, this is what a user would see when they enter an object. This is one of our most popular tables. If you look over here, you can see this table was mentioned a lot of times in our Slack channels. The most frequent users in their Slack handles that can be found. Their DAG, the refresh schedule of the table is also found here. and a bunch of other statistics. And all this data was automatically collected. For example, if someone says, hey, I want this to run 6 times a day, it'll automatically populate it here, and the user doesn't have to enter it manually. So we found out by automating these things, it can, the data in the Amundsen is not stale, and the automation is key part to it. Awesome. So, yeah. So at the end, I'm going to pass it back to Akira before that. But in case the message wasn't across, the importance of metadata is what I want to demonstrate, the data about the data. Without it, we get no context around it. So our metadata allows us to make our data more discoverable, observable, whatever that's supposed to mean. But the important context is what our metadata provides. So I'll pass it back off to Akira.
All right, so I know we've been dozing off, it's only natural with humans, so I'm just going to summarize the key findings. And so if you're going to pay attention, probably now's the best time to pay attention before we head off to lunch. So TLDR, let's go through them. Number 1, engage with the users, right? Communicate with them, see what questions they're asking, understand their pain points, because once you know that, you can leverage the metadata to address all of their requirements where possible. Number 2, most definitely model your metadata, right? By having a good generalized data model, it allows you to be adaptive to change and remain technology agnostic. Joe has stressed this, and we're gonna stress it too. Like literally, a good data model is a good generalized framework for you to use. And a lot of you will probably still ask why. Well, if you think about a large data space with ever-changing requirements, a good data model allows you to make it easily adaptable. For, let's say, whatever reason, let's say we are using Postgres now, we need to migrate it to MySQL. We've got the conceptual model there. Importers are logical, straight to the physical. No drama, right? Let's say we need to add another entity, for example, machine learning models or the users that are using our data or the queries, right? These are also entities. We can just add them in, no cooked relationships. It's there, it's transparent, and it's also not reviewed by just us, but also the wider data engineering team. So everyone understands what's going on. Number 3, make it easy to do the right things. We're only human, so we know that if you want to contribute metadata and give everyone more context, it's got to be easy, right? We're all lazy. So for us, 1 click away is the way to do it. Make it as easy as possible. And number 4, demonstrating value is the key to adoption, right? Past a certain population size, using the tool becomes part of the culture. When we first started off, right, we had to take Amundsen to people and plug it in. Here's a support question, here's Amundsen, these are the features, do you find it good, etc. Now, the users themselves are promoting it, talking about it, referring to other users about it. So we don't have to do that much work anymore. What can I say? We have an awesome culture, and I'm pretty proud to be a part of it. And lastly, automation enables scaling, right? We respect our peers' time, so we automate the boring stuff so that we don't waste their time. Get things to just work at a high enough standard. And it doesn't need to be perfect, but we don't take shortcuts, we follow best practices. Thank you, Patrick, for being there to make sure we always follow best practices because they exist for a reason, so don't take shortcuts. And so I just want to say thank you very much for listening to our talk, and hopefully you learned something valuable about metadata. Cool.